Hi students, welcome to Chemistry online classes. In the previous class I discussed about the aldenes. Now true isomerism. This is biphenyl system. Two benzene rings are there, all these substituents are present. Clear? So now here NO2 NO2 group is there. This is COH COH group. One phenyl ring is horizontal, another phenyl ring is vertical. So this phenyl ring is dotted line is like this. It means this is near to the observer, this is away to the observer. This part is not up here. That's a dotted line. This part is up here. That's a dark line. So this is horizontal. Actually, benzene ring only. For your understanding purpose, I given this is dark. This is dotted because of it is horizontal. This is vertical. Now, if you cut like this, then do you feel it having a plane of symmetry? If your normal structure is given like this, if it is given like this, NO2, NO2, COOH, COOH. If you cut like this, do you get the plane of symmetry in the middle? No, because left side what is it? NO2, right side what is it? COOH. If you cut like this, no. But if you cut like this, you will get plane. Which one? That is molecular plane. Now this is a pen. If you cut like horizontally, this molecule horizontally, half of the NO2, not this half front, this half back, but not like this. It is present in this form. So you will confuse that purposefully. First only I represented this. Molecular plane means what is that? If you cut horizontally like this, like slice, how you are cutting the bread slice, if you cut then you will get up and down like this. So this half part up, half part down, half part up, half part down. When you feel both are in the plane, but actually these are not in the plane. Actually how it is present? One is vertical, one is horizontal. But there is no compulsory, this is only horizontal, this is only vertical. It may be horizontal, it may be vertical also. It depends upon your consideration. Clear? So now, this is horizontal, second ring, this is first ring, vertical. Cut this molecule in any direction. You will not get the plane of symmetry. Because the first molecule having COOH, front side COH, back side COH. But here what is there? NO2, NO2. Then you are getting plane of symmetry or not? Plane of symmetry is there. Not there. NO2 half, NO2 half. Up and this one half. This small finger also half. This is COH, this is COH. If you cut vertically like this, NO2 half of front back, NO2 half of front back. This also front back you will get equal. Already I told in the last class also in aldene system or biphenyl system, vertically whatever you are cutting that gives equal. Vertically whatever you cut that gives the equal. If you cut like this it gives equal. Same vertically if you are cutting this one you will get equal. But here also what is there? COH, here also COH. Got the point? Then if you cut like this, these are mirror image to each other. Equal parts mirror image to each other. It having a plane of symmetry. Plane of symmetry present mean it is chiral or achiral? Achiral. So now I want to interchange this is COOH and here NO2. Now no plane of symmetry. When no plane of symmetry, before one is plane of symmetry present. Now plane of symmetry absent, center of symmetry also absent. Don't consider like this, these are center of symmetry present. If you consider like this, then what you will feel? Center of symmetry is present. But actually it is not like this. It is not in the plane like this. It is not plane. It is which one? One is vertical, another is horizontal. Then you may ask the questions are here C single bond is present, it is rotatable. If it is second one is horizontal, first one is vertical, if you rotate like this, then what you will feel? Horizontal. Then it is rotatable or not, that is a question. Got the point? Is rotatable or not, that is a question. Already we discussed in the geometrical isomerism What is the restricted rotation? One is double bond, another is cyclic ring, another is steric hindrance. So when you rotate this single bond like this, here NO2 group, here COH group, they are larger group. When larger group is there, steric repulsion, again it will not come like this, immediately comes to back. Try to coming to in this plane, but due to larger groups of the front and this back like this, again it comes to the normal same vertical position only. It will not be like this because of due to larger group. If smaller group is there, then it can be like this. Like hydrogen, deuterium, fluorine, like if it is there, that time it is normal in the plane. That's why we have to identify. Sorry, you told that different groups here, NO2, COH, NO2, but if any other groups, hydrogen, deuterium, fluorine or any other small group, like any, whatever that, oxygen like this, whatever it is, small groups are there, that time it is rotatable. Different groups also, but it is rotatable and it having the sometimes plane of symmetry. It depends upon that structure. So what you have to observe, different group also you have to observe and larger group also you have to observe. Got the point? So generally this is the molecule will give in the exams. Other also they can substitute any other groups, but you should find out larger group or not. Clear? So when these are absent, now center of symmetry is not present. Look like center of symmetry present, but not. Reason one is horizontal, another is vertical. So that is absent. Absent means total molecule is chiral or not? Total molecule is chiral. When chiral is there, that is optically active. Before here NO2, here COH is there, what is present? Optically inactive, because it is achiral. Now what is there? Chiral, optically active. Already I told you that optically active means what is the condition required? At least one chiral carbon. Only one chiral carbon is present, always optically active. More than one present may not be. So how to identify for optical activity? Symmetry element should be absent. What are the symmetry element? Sigma, center of symmetry, Ci. These are we are using for problem solving. Actually, we have to do experiment. In examination, we are not doing experiment. Therefore, we are choosing these two and to decide the optically active or not. In optically inactive, what is the condition? Achiral molecule is optically inactive, but some exception. They are do not having plane of symmetry. It means chiral carbon center is not there, but also they are optically active. Why they are optically active? Total molecule is chirality present. It means symmetry elements are absent. Allenes are symmetry element absent. Another is biphenyl system with the different groups. Symmetry elements are absent. Helicin also I told you that, but there is higher level you will study. But keep in mind, helicin is one of the molecule that also do not having the plane of symmetry and center of symmetry, that also optically active. Next one, meso compound. Meso compound means what is that? It is achiral compound. See, optically inactive condition, how many are there? Optically active, one condition. Optically inactive, three conditions are. One is achiral condition. Second one, what is that? Meso. Third one, racemic. Meso compound is achiral compound. Meso compound is achiral compound having two or more stereogenic center. SGC, you can write complete stereogenic center or stereo center, right? No problem. Why this is optically achiral mean? What is it? Optically inactive or active? Achiral meaning optically inactive. Keep in mind, meso compound always optically inactive. Why it is optically inactive? Already given in the last class in the rules. Due to what is it? Internal compensation. Internal compensation. So why it is achiral? Chiral having two or more stereogenic center, but also achiral. Reason Why this achiral we are stereogenic center present, but also we are considering which one? Achiral. Why we are considering achiral? Reason maybe sigma or Ci present. Maybe sigma or Ci present in overall model. Clear? One example we discuss. That is 2,3-dibromobutane. 2,3-dibromobutane. How to write? When name is given, how to write the molecular structure? 1, 2, 3, 4. 4 carbon, good word. At which positions are bromine is there? Second position, third position. Then remaining satisfied with the which one? Hydrogen. This is the 2,3-dibromobutane. Now I am writing in this form. Bromine, hydrogen, CH3, CH3. This is carbon, Now, which mirror image I am writing now? It is in mirror. Mirror may be denoted like this or dotted line. Anyone consider. Maybe like this denoted or maybe like this. Okay. Now mirror image which will appear? Bromine first appear or hydrogen first appear? In the mirror which will appear first? Bromine. H. Bromine. H. CH3. But some student will get the question mark. What is that? Bromine mean here Br. Then you have to write like this, no sir? Don't tell like this. Actually, how to write? Like this question also will get there because already I face so many problems in the classroom. So that I am telling. Bromine means like you have to consider this as sphere type. But here I am not drawing sphere. Only element symbols I am writing. So don't tell here R is there. R should be first appear. Bromine like this only I have to present. If you write also no problem, that is your choice. Now, this carbon, bromine one atom, hydrogen, methyl, and this total one, all are different or not around this carbon. Different in what you call asymmetric carbon or chiral center is present. Here also bromine, hydrogen, methyl, and this total one group. So it also having which one? Chiral center is present. Clear? Two are more stereogenic centers. Stereogenic center and chiral center already in the previous class I given very clearly. So now chiral center is present, but also it is optically inactive. Reason these may be anyone present. How? See, if you draw a plane like this is a plane. Bromine, methyl, H. This plane cut the molecule to equal halves. Otherwise, actually another word used, bisect means cutting. Okay? When you pause a plane, it bisects to equal halves. They are mirror image to each other. Then plane of symmetry present or not? So sigma is present. Sigma present means what we call achiral. Achiral means optically inactive. Its mirror image also optically inactive. Got the point? Now, these two are same or different? These two are same or different? Now we will not understand same or different. We will understand based on the RS nomenclature. But you have to remember me. Again, I will discuss this. Then you may be asked, sir, sigma is present here. Sometime maybe this is anyone present. Both may be present sometime. Or anyone present. That is called achiral. So I want to show this one also. How here center of symmetry present or not check? Center of symmetry present or not check? Possible? What is the meaning of center of symmetry? Draw a line from an atom or group through a center, extend the same length to the same atom or group. Okay? That is center of symmetry. Here possible? No. But it shows how if you take the Newman Sahar's projection. This is Sahar's projection already studied. Inclined line between the carbon. This is a carbon line. One group, second group, third group. 1, 2, 3 groups. Here also 1, 2, 3 groups are present. Clear? Now here I want to write CH3. In reverse I want to write this reverse. Staggered form this is. Then here CH3. Then this is Br, this is Br, here H, here H. Now here in between this is what is there? Center of symmetry is there. If you take this is also center of symmetry is there. If you take this is also center of symmetry is there. So Ci present here. Therefore optically inactive. You have to remember this. What is a meso compound? In now, if they may not ask in the competitive in PU exam, also they may ask in the haloalkane chapter second. So that this example you can write. Now, meso compound example. Optically inactive means what is the condition? Achiral meso. And already I told you that internal compensation. Why it is optically inactive? Due to internal compensation. So already given like this polarimeter diagram. In the polarimeter, what will be there? Compound, organic compound. Now this organic compound I am taking here. This organic compound. Which one? 2,3 dibromobutane. Now I am causing the plane polarized lights. Plane polarized light. Then here we are observing in the plane. This is right side, this is left side. This half of the molecule rotates right side, for example, plus 10 degree. This rotate which direction? Right side direction. This half of the molecule rotate left side with the equal magnitude. This is minus 10 degree. Minus 10 degree. Then resultant how much? 0. Then when 0 is there, optically active or inactive? Inactive. 0 is there, optically inactive. So why meso compound is called due to internal compensation optically inactive? Reason, half of the compound rotate right side, another half of the compound rotate left side. Equal magnitude, then resultant that observed rotation is 0. Therefore optically inactive. So this word they are using in the competitive exam. You have to concentrate. What is the internal? Internal means we are not doing any extra. Itself only. Okay, internal that molecule only showing you. Now another one. Racemic mixture. Racemic mixture. What is the racemic mixture? Equal amount of 2 enantiomers. Otherwise, equal amount of enantiomer pair that is. One pair means how many molecules? 2. Pair means 2. So equal amount of 2 enantiomer. Enantiomer means one pair. So now it is called 1:1 or 50%, 50%. Equal amount of enantiomeric pair. Enantiomer equal amount of equal amount of 2 enantiomers. That is called racemic mixture. Clear? Equal amount of 2 enantiomer. Enantiomer equal amount means what is it? 1:1 or 50-50%. Then only racemic. One is 25% and this is 75%. Equal or unequal? Unequal. Then that is optically active or inactive? Now the question is, racemic mixture is optically inactive. Already given in the previous classes. Optically inactive. When equal amount is there. If it is unequal amount, that is not called racemic mixture. See, one compound A and B. This is 50%, this is 50%. What do you call this? Is racemic mixture. Racemic mixture is optically inactive. 50-50 racemic mixture optically inactive. If one compound having 60, that is A, another is B, that is 40, then this is not racemic mixture. Not racemic mixture. When not racemic mixture, then it is optically active. Optically active. Then you may ask the question, sir, how it is optically active? Racemic mixture means what is that? 50-50%. It is 40-40. 40-40 racemic mixture. Remaining extra how much is there? 20. The 20 is overall optically active. Got the point? Here 40 is there, here 40 also is there, B molecule. 40 racemic mixture. Remaining extra how much is there? That 20% of molecule is optically active. Clear this is? Then don't confuse with this. So now, already I told you that racemic mixture is optically inactive due to external compensation. External compensation. Now consider this is a polar emitter. Here one test tube is there. Now we are passing the plain polarized light PPL. Here one organic compounds are there. KBL, all of you. KBL. First I have the one enantiomer A. One enantiomer that is A. Now externally I am adding that is B enantiomer. First one A is there. Second one what is that? B. First one having the 50. Second one also having the 50. Then equal or unequal? Equal. Then equal amount of two enantiomer, what you call? Racemic mixture. Then here in the plane, this A molecule rotated, for example, left side minus 5 degree. This B molecule rotated right side plus 5 degree. Then resultant, what is that? Theta. Generally alpha it is, alpha in the textbook given, alpha. Then how much is it? 0. Resultant observed rotation is 0, means optically active or inactive? Inactive. Therefore, this racemic mixture is always optically inactive. Why optically inactive? When equal amount. A molecule rotated right side or left side. That we are not telling. Just imagine here. For example, right side or left side. Which one you want? A molecule left side concern 5. Right, B molecule rotated right side. Equal amount they are rotating. Then resultant is 0. Therefore optically inactive. Therefore it is called optically inactive due to external compensation. Why it is optically inactive? External compensation. It means individually each enantiomer, if B is not added, A is active or inactive? If B is not added, then A is active or inactive? Active. A not only B is active or inactive? Active. Together equal amount inactive. Together unequal amount active. Got the point? So I already given there. Together A and B unequal amount active. Together equal amount optically inactive. Individually they are active. Don't forget the statement. Here external compensation, here internal compensation. Clear? So these are the conditions over. With this optical activity part completed. Now already told you that these are identical or not. How to identify based on the RS nomenclature. These are the prefixes in the IUPAC name. Prefixes. What are the prefixes we are using in the optical isomerism or geometric, stereoisomerism? One is cis trans, another is EZ, syn, anti. These are already completed. Geometrical isomerism. In stereoism, another prefixes are RS. Now we have to discuss. Another one is DL. This DL nothing but in the previous class only I told. If rotate right side, dextro, that is denoted with the plus. If rotate left side, that is called leo, that is denoted with small l or minus. This is already completed. If you want one time again I will discuss. Now I am discussing RS nomenclature. RS nomenclature. Now R meaning what is the rectus. S meaning sinister, not sister, only sinister. Rectus, sinister. Rectus means right side, not right. It is, do not indicate the direction, only right it indicates. Sinister means what is that? Left. Okay. Now In RS nomenclature, the first rule is identify or find. Identify chiral center. Identify chiral center. Second one, give priority to atoms or groups which are directly bonded to chiral center. CC means chiral center. Give priority to atom or group which are directly bonded to chiral center. Okay. Third one rule. Then how to give the priority? Already given in the EZ nomenclature. Refer this. In EZ nomenclature given this. Higher atomic number, first priority. Lower atomic number, next priority. If atomic number same, that is called isotopes. Then we have to follow higher atomic mass, first priority, lower atomic mass, next priority. That already EZ nomenclature, the rules are there, that same you have to follow. The rules name what you call? CAP rule. CAP means what is it? Kahn, Ingold, Prelog. These are the scientists' name. Kahn, Ingold, Prelog. These are three scientists given this rule. Kahn, Ingold, Prelog rules that are already given in EZ nomenclature. The third one is I will write here. Third one. You know that car steering will be like this. In any car, you can observe this three spokes will be there. Steering. Now, priority 1, 2, 3. This clockwise or anti-clockwise is clockwise. Clockwise meaning R. 1, 2, 3. This direction clockwise only. Yes, sir. This is clockwise. This is also clockwise. Yes. Common. Don't think because one R is there, another yes you are thinking it. To avoid that I am doing here. So now number change. If it is number how to give? Anti-clockwise. Here 3, here 2, here 1. Then it is anti-clockwise or counter-clockwise. Okay. Then what it indicates? Yes. Clear? This is the rule you have to follow. Now. CH3, Cl, Br, H. Now I am drawing this mirror image. H, CH3, Cl, Br. Clear this is? What is the first rule? Identify chiral center. Chiral center is there or not? Chiral means all four groups are different are there? Yes. Second one, give the priority to atoms or group which are directly bonded to chiral center. How to give the priority based on that CAP rules. Higher atomic number first, next next atomic number. Bromine 35, chlorine 17, carbon 6, then it is third, then here this is the fourth. Okay? Then here you may ask 1, 2, 3 only is there, but here up to 4 is there. Fourth one we are not considering here. Fourth one not considering. Only 1, 2, 3 only. Now how to give 1 to 2, 2 to 3. See 1 to 2, 2 to 3. Which direction this is? Clockwise or anti-clockwise? Clockwise. Clockwise meaning what is it? R. This is R configuration. Clear this is? Now here also number 1, second priority, third priority, fourth priority. 1 to 2, 2 to 3. Which direction this is? Anti-clockwise. Then what do you call? Yes. Now I will write one more here. CH3 and Cl, Br,